All right, so we'll continue what we studied. We discussed about the homologous series, the basics of organic chemistry, and types of reaction as well. Now, the next type of reactions are for bond breaking because you know that in organic compounds, what is that bonding that is between them? Covalent bonding, right? And covalent bonding
Yep.
is the sharing of electrons. For example, chlorine
And
have
hydrogen.
shared a pair of electron, right?
Mm-hmm.
Okay. Now there are going to be when this bond has to be broken. ठीक है बॉन्ड क्यों ब्रेक होगा बिकॉज फॉर एग्जांपल एडिशन रिएक्शन ऑफ क्लोरीन इफ दिस chlorine has to react with CH4 to form CH3Cl, one of these Cl has to break down, right? They have to break away from each other. Now there are two ways of
Yeah.
break. The first way is that they break homolytically. This takes one and this takes one back, ठीक है, and they both remain atoms. The other one is known as heterolytic. One of them takes both of these and the other one gets nothing. Got it?
Okay.
So this is known as homolytic fission and this is known as heterolytic fission. Homolytic fission means same and lytic means splitting. In homolytic fission, the shared pair of electrons in the covalent bond divide equally between the atom, and this can be shown over here like this. You can see here. Each product species keeps one of the electrons from the covalent bond, and these species are called free radicals. And each free radical has an unpaired electron and it is uncharged. Heterolytic fission क्या होती है? Can you explain me now?
Uh, is it the way of splitting an electron in two pieces?
Heterolytic fission would be that the bond pair between the जो है electrons, both of the electrons will be taken by any one of them. So leaving one of
Yep.
them positive charge, leaving the other one और दूसरा वाला जो है वो हो जाएगा negative charge. यहाँ पे तो
Yes.
both of them remain atoms, right?
Yep.
ठीक है यहाँ और इनको हम कहते हैं radicals. ये free
Yeah.
radicals and they are able to bond with anyone they want. ठीक है and keep your mic closer to your mouth.
Yeah. But this
The
one becomes
left-hand product
ions.
species keeps both of the electrons from the covalent bond and this species is a negative ion. The right-hand product species does not keep either of the electrons from the covalent bond and this species is known as a positive ion. Heterolytic fission could also occur like this. You can see, ये देखिए,
So it takes
one of
both.
them has taken both of the electron, the other is left with nothing.
Nothing.
Good.
So same as the other. Yeah.
Exactly. Electrophiles and nucleophile are two main terms. Electrophile means electron liking. They are the poor ones, which do not have an electron. मतलब they need electron, the positive ones. जैसे Cl
Okay.
positive बन गया था after heterolytic fission. These are known as electrophiles. And electrophile
Yeah.
refers to a chemical species that likes negative charge because itself they are positive in
Positive.
need of
So
electron. You remember the opposite charges, they attract each other.
yeah.
And the positive ion produced by the heterolytic fission will be attracted to a region of high electron density in other molecule. Now, this one was left with nothing. This has
Yep.
become a plus sign and it's going to attract
Positive.
to any atom that would be having
Which is
electrons.
yes.
The one having electrons is known as nucleophile, the rich one.
Yeah. This is
This
a
is the
negative.
rich one, the one with very, very electron. ठीक है, a lot of electron. This is the rich one. Clear?
Yeah.
So these are the terms that you have to keep in mind when we'll be studying organic
Is it
chemistry.
necrophile? What was said?
Nucleophile, nucleo.
Nucleophile. Okay.
Nucleus से
Nucleo.
निकला nucleophile, ठीक है? This is the last topic of your topic number 4A, and then we'll start off with topic number 4B after solving some questions because this needs a lot of question practice, and going to do it in the class right now. I don't know
Okay.
why have they added this topic, but it's the first time I'm reading as well. This is just added. Let's see what this is. It's called as hazards, risks, and risk assessments. ठीक है? Uh, Safety in chemistry
This is just
laboratories.
safety instruction
Yeah, I
like
guess it's the
gloves and
basics. I
stuff.
don't know. They have just added it
Gloves and
in the syllabus
masks.
last year. तो इसको देख
This
लेते हैं
new
जल्दी से
syllabus.
पता नहीं क्या है इसमें. I guess these are some safety signs, hazards that can occur in a laboratory and you have to, I guess, memorize them. No questions. I haven't seen these questions. I don't know. You will be the first student who will be giving these papers with this topic. So incidents that cause harm to people are rare in school and college laboratories. And one of this reason is that laboratories need to consider the hazards of doing chemistry experiments and use safe methods of working. This applies to all chemistry experiments, but especially to those involving organic compounds. It is particularly important in experiments that you plan yourself. And when you plan, for example, an organic synthesis, you need to consider all the hazards that are associated with the reactor so that you can be prepared for those as well. So hazard and risk में कोई फर्क है. Hazard of a chemical substance relates to the inherent properties of the substance. What are the different properties making it dangerous? And the risk is that you are using that hazardous substance and you
Mm-hmm.
have a higher chance, higher risk, मतलब higher chance of getting the harm from that hazard. Most
Mm-hmm.
people
Yep.
would consider that water is completely safe and has no hazards. In more situation, this is the case. However, consider a beaker of water being boiled or a tripod or a gas. Now, water isn't safe. What if you are boiling it? It's not safe.
Yeah.
The steam coming out of the water, the boiling water itself could both cause harm on your skin as well, to your eyes as well. And consider the most people would consider hazardous as well. You have probably used hydrochloric acid in experiments involving marble chips as well, and you will have been told to use eye protection when using the acid because of the harm it could do, especially if it got into your eyes. The hazard exists because hydrochloric acid is corrosive, and so it could damage your eyes as well. The risk depends on how likely it is that the acid can get into your eyes. And for example, using gloves, protections, eye protection, goggles,
Mm-hmm.
जिसको हम कहते हैं ये होने चाहिए. So a
Yeah.
long time ago, these symbols started to come on bottles, on your laboratory walls, and everywhere. And they had now become very well intentioned that what are harmless substance, what are harmful substance. There were proper labeling that was done. For example, pictograms आने लग गए थे, which have been used to label substances, but also to identify the actual hazard of the substance inside. The actual symbols have changed over the years, and you may see older and newer types together in the same laboratory. Older ones are often square in shape with the orange background, such as these, and the symbol nowadays that are used are the red diamond shapes. I don't know why are we studying this. Okay, this is the old version. ये वाले. You must have seen this in your science books when you studied in class 6, 7, and 8, right? तो ये उसमें होता था. Your general science books, you have seen these pictures before. Now, the new ones that is used is the globally harmonized system of classified labeling of chemicals known as GHS. This is the new system indicating health hazards, including warming on skin rashes, eye damage, ingestion, what is corrosive that can cause skin burns and permanent eye damage, flammability, something that can catch fire if you're in contact, acute toxicity can also prolong to life-threatening effects as well if used in small quantities. In some cases, the substance may have more than one symbol. What would that indicate? Having more than one symbol, because it has more than one types of
Is it
hazards.
yeah, multiple hazards?
Multiple, exactly, especially when it is in an aqueous solution. Aqueous solution तो एक mixture है. For example, you are
Yeah.
likely to use hydrochloric acid in three different concentrations. 0.1 भी होगा. Now, greater the concentration, every different concentration would have multiple hazards. 0.1 would have one hazard, but 10 mole per dm cube can be flammable as well, toxic as well, corrosive as well,
Mm-hmm.
more harmful on skin as well. तो उसके multiple hazards होंगे, even if the concentration is higher as well. The
Yeah.
person in charge of the laboratory or any other place of work is responsible for making risk assessments. First, they look at the hazards of all the chemical substances being guided by the hazard symbols, and then they consider the ways in which these substances will be used. This is known as assessing the risk. And finally, they write down some guidelines for those who use the laboratory. We call these the control measures, जिनको हम guidelines कहते हैं, standard operating procedures. You have heard the term of SOPs. What is SOPs?
Uh,
A set
SOP.
of rule, criteria, guidelines, directions,
Okay.
ठीक
So,
है, जो कि standard operating procedures होते हैं. Such guidelines will be considered many different factors, including the guidelines would depend on the amount used. Why? How?
because obviously, if there's small dose of it, it might not have as many hazard as maybe 10
Exactly.
milliliters.
Age and experience.
Yeah.
How is that a reason?
I guess the maybe
Tell me.
like Mm, I don't know how to say it, but
How much is he an expert? Is he an old person? Is he a kid? Is he a student? Whether or not heating is involved, the guidelines also depend on how strict would the guidelines be if there's heating be used. Is there ventilation? Control measures कैसे होंगे? This is a common question that I guess will be asked. This is a good question. Different control measures. Eye protection, gloves, cap
yeah.
on the bottle, always keep the substances away from the source of heat, and always clean the substance when it is spilled on the floor or on the skin as well. Remember that there are also hazards and risk in your home as well. Many cleaning material आपने dishwashers देखे हैं, फिर आपने window cleaners देखे हैं, फिर you have also seen other acid being used in toilets as well. They all have a warning label for a household. Even जो cleaner होते हैं, they all contain acids कि इसको सॉलो ना करें, आई से दूर रखें, स्किन से दूर रखें, इसके सब्सटेंसेस हैं इतनी ज्यादा एंड स्टफ एज दैट. Apparatus,
Mm-hmm.
what is apparatus?
The equipment you may use.
Exactly, the different equipment, the different instruments that are used in chemistry laboratories. Some of this apparatus may also have hazards. For example, mercury thermometers obviously contain mercury, which is a hazardous substance, and this is why you are more likely to use spirit thermometers and digital thermometers. Their hazards are much lower. Another example is methods of heating. And traditionally, heating involved the use of Bunsen burner, tripod, and gas. Perhaps an electrical heating mantle would also be safer and easier to use as well. Organic chemistry also involves a lot of glass apparatus. तो glass break हो सकता है, sensitive होते हैं to heat as well. और उसके बहुत छोटे छोटे pieces हो जाते हैं. Remember, the hotter the temperature of your glass, the more the pieces it would shatter into. The colder the temperature, it's only going to shatter into less pieces. Remember that. A long
Yeah.
time ago, the traditional way to connect the different pieces of glass apparatus was by using connecting glass tubing crop with rubber bungs as well. Different joints used करते थे, and they used to be less hazardous. So, hazard is something that could cause harm to a user. Risk is known as the chance of hazard causing a harm, and risk assessment is the identification of the hazards involved in carrying out a procedure and control measures needed to reduce the risks from these hazards. Got it?
Yeah.
And that is the end of your topic number 4A.